Welcome back. I'd like to go through example 3C for you. So just like I said before, on any of these problems like this, there are several ways that you could attack the problem, and depending on how you round, your answers could be slightly off, so just be aware of that. So let's see what we're given. We're given pH, and I want to get H plus, OH minus, and POH. So if I was doing this problem, I'd start with getting POH first. Again, there's all kinds of methods you can do. We know 14.00 equals pH plus POH. Excuse me. Okay, so then we're going to take 14.00 equals 4.67 plus POH. Now to isolate POH, or to get it by itself, I'm going to subtract 14 minus 4.67. And I get a pH, pardon me, misspoke, a POH of 9.33. And now I'm going to find the H plus concentration, the OH minus concentration. So to do that, let's look back for just a moment because it's been a while since I referred to them. We haven't used this formula yet. Let's look back to the formula here where we can solve for H plus. So these two formulas is what I'm referring to. I can get H plus concentration and OH minus concentration by using the 10 to the negative x button. Let me show you. That would be the second function, or the 10 to the x button on your calculator. So let's go through that example. So I can say H plus concentration equals 10 to the negative pH. So in this case, 10 to the negative 4.67. So let's go through that on our calculator. I'm going to go through it on my calculator. Obviously, you can't see me using my calculator, but you do need to use the second function of the LOG button. So I'm going to put, on my calculator, I have to put the negative symbol in first. So I'm at 4.67, negative 4.67. So however you have to put that in, but you're going to make it negative 0.467. So you're going to take your pH and make it negative, and then hit second log, and it should give you a answer of 2.14, I'm rounding, I'm not applying sig fig rules properly, 2.14 times 10 to the negative fifth, and that's going to be a concentration. Now there's several ways that we could go about doing this next one, okay? We could use the 1.0 times 10 to the negative 14th equals H plus times OH minus. I like to go ahead and do OH minus equals 10 to the negative POH. So in this case, 10 to the negative 9.33. This is just one method. You could have done the other method I mentioned here a moment ago. So I'm going to take negative 9.33 and I'm going to hit second log, and I'm going to get, for my OH concentration, 4.68, rounding to two places past the decimal, not following sig figs, to the negative 10th concentration. So I have solved for all of these pieces. I have solved, and I did it a little bit backwards. Doesn't matter what order you do them in, because there's several approaches. I have gotten all three of my answers. Now I'm going to identify if it's acidic or basic, which you could have technically done in the very beginning. We would say this is an acid or acidic, and we could justify that by saying pH is less than 7, or you could say H plus concentration is greater than OH minus concentration. So our H plus concentration here is to the negative fifth, and our OH minus concentration was to the negative 10th. That's how I could use either of those two pieces to identify that it was acidic. That's the end for example 3. Thank you.